This is a tutorial on distributed workflow in Git. So we can see when we run git remote that we don't have any remote repositories that we're tracking. So for our simple Git project, we're going to create a new repository. And as the creator of this, we're going to put our public repository on my personal account on GitHub. So you can see what it's like to push and pull from GitHub. And this tutorial is going to take two different roles. One of the person who created the repo and maintains it, and another of a contributor. And so this first role is on this tan screen here. And you can see that we've created our new account on GitHub. And we need to add it as a remote. And so we do git remote add, the name that we want to refer to it as, and then the private URL that we have, which is over SSH. That git at is the git user at GitHub. That's actually an SSH URI. So then we git push, and then the name that we're calling it, which is GitHub master, and we can see it go up there. So now this is our second role, and you can see that we don't have the simple Git project yet. So we're going to find out what the public URI of that is on GitHub. And that's the clone URL. So we're going to copy that, and we're going to run that clone, which will get us a copy of that over the Git protocol. So the first one was the push was over SSH. This clone is over the Git protocol. And now we cd into the directory, and we have all the files. And we can see that Git has automatically added this as the name origin as the remote. But we could change that. We could name that whatever we wanted to. So now, as a second user, as a second role here on this green screen, we're going to change the name of the person that we're working as so that we can differentiate between the commits. So the way that you change that on a global level is you do -- global, as we went over in the first tutorial. But for a individual project, we can just run git config user.name user.email, and that changes it just for this single project. So now if we run git config -list again, we can see that we have a new username and email that will supersede the old one. So let's make a change. So again, we cloned this from the originator of the project, and we want to contribute to it. So we're going to make a new function, and then we're going to send a pull request to the original maintainer, to the maintainer of the project. So we'll put in a new function into this Git library that says ls files. It doesn't really matter what the change is for this. And then we're going to add ourselves to the project as an author. This is my alter ego, Magnus. So now we're going to commit these changes, and then we're going to set up our own public Git repository. So this is our private repository. We're going to set up our own public Git repository and then send a request to the original maintainer to pull changes from us. Now, we can't push to the origin. When you try, you get this remote end hung up unexpectedly because you can't push over the Git protocol most of the time because it's unsafe. There's no authentication on it. So what we're going to do, since we can't push our changes back to where we got it from, is we're going to set up our own public repository. We're going to push them there, and then we're going to ask people to pull from us. So I'm going to change directories into this directory where Apache is serving documents out of. And to demonstrate that it's just serving static files, I'm going to create a new static index file and make sure that Apache is serving that properly. And unlike Subversion or something, you don't need WebDAV or anything special to serve Git repositories over HTTP or HTTPS. All you need is a static file server. So we can see that our change, the index file is red, so that's where Apache's document root is. So we're going to do what's called a bare clone of our repository and put it there. And a bare clone is just, you say that the repository where it is and what you want the new bare repository to be, And all it does is create a copy of the .git directory, basically, without the working directory checkout. So it's basically just it's very similar to just copying the .git directory. So now we're going to put that sg.git, that's a directory, um, into the place where we're serving our static files, and you can see that we can read the head file just fine. So you can access the contents of your entire Git repository over HTTP, over the dumb protocol. And you can see it's just a normal Git repository. So now, back to our original role, we're going to add our new friend as a remote so we can push him, or so at least we can pull from him. We're not going to be able to push from him, but we can pull from him so that he can send us email saying, I have a change, and we can pull that, check it out, maybe integrate it, and push it back up to GitHub that we're maintaining. And that combination of public and private repos for each contributor is a very common one. So you can see that we added him as a remote, and we gave him the name new friend, but we couldn't list we couldn't find anything on that. We couldn't fetch from it. And the reason why is because on a dumb protocol, you have to run update server info like this, and it adds this info refs file. And that is one file that lists out all the heads and shaws that you need to get, because you can't list the contents of these directories. Over HTTP doesn't have a list command. So you have to aggregate it for it. So you have to run that every time. So now if I run ls remote on my new friend, I can see the head that I need to get. And if I say git fetch, I can pull down the objects that I'm going to need, the objects that have changed, the objects I don't already have. So now if I run rev parse, that'll give me the SHA of anything. And I can see it's 710f, and I can see that the tree of that is FAD6. And so now if I go back, I can see 710f and FAD6 as the objects that were fetched. So I can verify that I got the new commit in the new tree. And if I run git diff, I can see the lines that I added. So now I haven't integrated this into any of my local branches yet. I've just pulled those changes down so I can see what they are first. So I haven't actually modified anything locally. And I can see my new friend's commit there, Magnus Chacon. And now I can rebase his changes on top of mine, or merge, or whatever you want to do. In this particular case, it's a fast forward anyway, so it doesn't really matter. So now you can see my master is the same as his. And GitHub is behind, so we're going to have to push our new changes out to GitHub. Now, every time I make a change, I need to run that update server info for anybody to be able to pull those changes back. So instead of trying to do that every time that I push into my public repository, I'm going to Git actually comes with a hook to run that automatically. And in this particular case, that's in the post update script. And it just runs git update server info every time that you do a push into this repository. So to enable it, we have to make it executable. So we're going to run that. And now every time we push into this repository, it should automatically run that for us. So we don't have to worry about doing it every time. That's only something you have to do on the dumb transports, HTTP or HTTPS. So let's go in here. We'll make a change, something really small. We'll push it back in, and we'll make sure that our friend can pull that change again. But in order to do that, you'll remember that Now you can see our change. And where are we going to push this, right? Well, we're in a different directory. Remember, we cloned the one, and so we need to go to our original working directory that we make our changes in, and we need to add our public repository as a remote that we can push to. And you can add local directories, local repositories as remotes. So we're going to do git remote add local, and local is just a handle. We can name it anything we want to, my local, whatever, and then a relative path or an absolute path in this case. But and then we can push into that. Now on our original role, we can run an ls remote on our friend again, and we can see that that remote has that shell has changed. And so if we do a fetch, we can get the new objects again. So the server update info obviously worked. Now this time, I'm going to make a change, and then the other guy's going to make a change, and I'm going to have to rebase on top of that. So I'm going to show you what that looks like. So let's make a change. We'll add the cat file-t command as a new call that we can make a new method in our Git bindings, and we'll go ahead and commit that. And we can see that at this point we've branched, right? We've pulled down our new friends' changes, we've made changes, we haven't merged them together yet. So in order to do that, what we have to do is we have to have a local branch that is a remote branch. We can't check out a remote branch. So we need to have a local branch that we can check that out into. So here we're going to create a new branch, just fr for friend, and we're going to check it out, new friend / master into that local branch. So now we have their changes in a local branch. So now we're going to rebase that local branch, and that should have the changes that we're looking for. So it looks like we did our change and then they did their change, even though in reality it actually happened the other way around, but we've changed the commits around. So we can see that the FR and the remote's new friend master are the same commit. It just looks like they did theirs after ours. So we rebased their change on top of ours. So now if we go to the master and we merge that local branch, it just does a fast forward. And now our master has the change we did and the change they did. And the interesting thing about doing it this way is that it rewrites the commit, and it changes it so that you are now the committer on it, but Magnus, the original author, is now the author on it. So that's the situation in which you can have different authors and committers. And now if we push this, if we just look at this from, if you don't add the -- all, we don't necessarily see his remote because it's not in our history. And it looks like a nice clean history. So now if we push this to GitHub, other people can share these changes, both the ones we did and the ones that they did. And you'll see if you go to a repository like this that we now have Magnus as the author and S. Chacon as the committer. And rebase is generally how that happens. So that is a distributed workflow within Git.